Let's look at an example of using the root test. Now, what, first of all, works well with root test? Well, think about what you're going to take the limit of. You're going to take the limit of the nth root. So things that are already to the nth power, if you take the nth root, you're going to get rid of that nth power. So often things that are raised to the nth degree, like what we have here in this example, that natural log is anyways, you might want to think about using root test. Now this n is not to the nth power, but when we take the nth root of n, we have theorem 5. So we're in good shape there. So when you see a lot of stuff being raised to the nth power, think about root test as an option. So let's just set up our rho. So rho is the limit as n goes to infinity of the nth root of the absolute value of that. And again, this says really any series, so you don't have to check about these terms being positive or anything like that. So what do we have? When you take the nth root of natural log to the n, that's just going to be the absolute value of natural log. So let's simplify this a little bit. So we're going to have the nth root of n when we take that root at the top. But on the bottom, we're just now having natural log of n, an absolute value. Now, natural log of n is not negative, right? Natural log is positive for n, well, bigger than e, so 3 or bigger. Notice how they started this at 3 for us. So I could really drop the absolute value on that, and same thing on that. But I could actually evaluate the top. We know from theorem 5 that that top limit is 1. So we'll just evaluate that. So that's by theorem 5. And we know natural log grows without bounds, so this is going to infinity. So we have a non-zero constant over something going to positive infinity. That is 0, which is less than 1. Remember our criteria, we compare with 1. So that tells us then our series converges. And our series was n over natural log of n to the n from 3 to infinity. All right, so kind of looking back over these two tests, some could go either way. Some work fine, ratio and root. Remember, in ratio, I said things that were like an exponential to the nth power worked good in ratio because of the canceling. They also work great in the root. And root is a little bit faster, I think, just a little bit less writing. But either way would work. The one thing that's not interchangeable is factorials. Remember, factorials work great in ratio, but the nth root of n factorial is not a limit that we know. So we don't want to be applying the root test to factorials. So keep that in mind when you're making your decision.